Hello everyone, welcome to Maths with Math Tips. In this video, we are going to discuss the 3 questions from NBHM PhD 2021. Question number 18, which is from complex analysis. Question number 27, which is again from complex analysis. And question number 25, which is from linear algebra. This is the part 7 video of NBHM PhD 2021 solution series. If you are not watching the previous videos or previous solutions, I am sharing the link in the description and also here in the I tab. If you like the content, then please give a like to this video. If you have any doubt, then leave a comment in the comment section below and don't forget to subscribe the channel. So let's start with question number 18. Question number 18 says that let D be the disk in the complex plane centered at the point pi by 4 and radius r. Let D dash be the image of this disk under the map z to sin z. Evaluate the following limit r tending to 0, area of D dash by area of D. This is a very interesting and important problem, this type of problems. So suppose this is the z plane and this is the w plane. So given that the disk is D is such that z such that mod of z minus pi by 4, which is less equal to or less than r. This is the disk, this is a circle with center pi by 4 and radius r. So this is suppose the point pi by 4 is the center and this is the w plane and the map is f. So f equal to sin z. That means the mapping w, this is equal to fz, this is equal to sin z. Now let any point on the, and this is D and this is suppose D dash. So any point on the boundary of D, this is equal to pi by is of the form pi by 4 plus r e to the power iota theta. This is any arbitrary point on this boundary. So and this mapping is fz equal to sin z. So the center pi by 4 maps under this map. So z to w, the map going to sin pi by 4. So this is the image of center under f. So this is equal to 1 by root 2 in w plane under the map. Now we find the image of this arbitrary point which is situated on the boundary of this disk D. So the image is sine of image of the point pi by 4 plus r e to the power iota theta in w plane. This is equal to sine of pi by 4 plus r e to the power iota theta. And note that this is a point with a fixed distance from this point pi by sine pi by 4 with a fixed point, that is the image of this disk D under the map D dash under the map F. This is D dash, this is also a disk with center sine pi by 4 and any arbitrary point on the boundary of this disk is sine of pi by 4 plus r e to the power iota theta. And this is since a fixed distance from the center, radius of the disk D dash, this is equal to mod of the center minus this point, since the center is sine pi by 4 and any point on this boundary is equal to this sine of pi by 4 plus r e to the power iota theta. This is any arbitrary point on the boundary. and we note that the radius means center distance from center to any point on the boundary. So this is equal to sine pi by 4 minus sine pi by 4 plus r e to the power iota theta. This is the center. So now this is equal to 1 by root 2 minus sine pi by 4 cos r e to the power iota theta plus cos pi by 4 into sine of r e to the power iota theta, this one, and value of cos pi by 4 sine pi by 4 both are 1 by root 2. So 1 by root 2 into minus 1 by root 2 common, and cos of e to the power r e to the power iota theta plus sine r e to the power iota theta, this mod. So take common 1 by root 2, then 1 minus sine r e to the power iota theta minus cos r e to the power iota theta, this one. Now we can write this 1 minus cos theta, this is equal to 1 by root 2 into 1 minus cos 2 theta means 2 sine square from this and this, 2 sine square r e to the power iota theta by 2 minus sine r e to the power iota theta. Now we have to find the area of d dash by area of this. So d is a disk with radius pi by 4 and center pi by 4 and radius r. So area of this circular disk is equal to pi r square, and suppose the r dash is the radius of the circular disk d dash, then r dash equal to this one. So this is, since also a circular disk, so this is also pi r square, area of this pi r dash square, the area of d dash. That means we can write area of d dash by area of d, this is equal to pi r dash square by pi r square. So this is equal to simply r dash square by r square. Now taking limit as r tends to 0, area of d dash by area of d, this is equal to limit r tends to 0. Now r square means simple put the value of r square, and r dash square means this is 1 by 2 into this square, so we can write 1 by 2 into 2 sine, and since we write square, mod of 2 sine r e to the power iota theta by 2 minus sine r e to the power iota theta mod square, this one. So this is equal to half limit r tending to 0. Now here another one note is, we take an arbitrary point on this disk, boundary of this disk, and get an image of an arbitrary point which is situated on the boundary. Now जो थीटा हम लोग यहाँ पे लिया है आर्बिट्ररी पॉइंट का, थीटा का रेंज क्या होगा? थीटा का रेंज होगा यहाँ पे 0, थीटा का जो रेंज होगा 0 लेस देन थीटा लेस देन 2 पाई. This is the range of theta in this disk also, and here in this disk also, image disk, in the image disk also. So now if we put theta equal to 0, then there is no problem, since we find the radius means the distance from any point, so we can put any value of theta in between 0 to 2 pi. There is no problem, since radius means distance from center to any point of the boundary. So this is, we should fix the value of theta at theta equal to 0. There is no problem. So this is equal to, you can write mod of, and you can write simply sine 2 sine r theta means 0 means 2 sine square r by 2 minus sine r whole square giving r square. So this is equal to 1 by 2 limit r tends to 0 2 sine square r by 2 minus sine r by r whole square. This is equal to half limit r tends to 0. This is sine, we can write this is of the form sine r by 2 by r by 2 into sine r minus sine r by r whole square. If we apply the limit, then the limit, this limit equal to 1, this limit equal to 0, and this is again 1. So we get simply half into 0 minus 1 whole square. So this is equal to half is the answer of this problem. The area, the required, evaluate the following limit is equal to half. Now go to the next question. Question number 27. Question number 27 says that find the smallest positive real number k such that given any finite set z1 z2 zn of complex numbers all with strictly positive real and imaginary parts, the following holds, then find the value of k. That means z1 or zk equal to take ak plus iota bk, where ak bk non-zero, since it is given that all strictly positive greater than 0, strictly positive real and imaginary parts, then which of the following is true. So now we start with this mod of z1 plus mod of z2 plus mod of zn whole square. This is equal to mod z1 means write mod of a1 square plus b1 square, and similarly for mod z2 mod z3 and so on. So this is equal to root under a1 square plus b1 square plus root under a2 square plus b2 square plus so on plus root under an square plus bn square. This. Now we know that result such that m plus n whole square, this is equal to, we all know this formula, m square plus 2mn plus n square. Now this is equal to this, there are three terms. That means we can simply write m square plus n square, यहाँ पर और एक वैल्यू ऐड है तो इसका इक्वेट हुआ है, इक्वल हुआ है. सो यू कैन राइट दिस इज लेस देन और इक्वल टू m plus n whole square. And if we apply both sides square root, then we can write m square plus n square is less equal to m plus n, taking positive square root this. So each of a1 square plus b1 square and e2 square plus b2 square, we can write a1 plus b1, a2 plus b2, this simple inequality. So this is, we can write less equal to a1 plus b1, and sorry, this is squares, a1 plus b1 plus a2 plus b2 plus an plus bn whole square, this one. So this is equal to, we write a1 plus a2 plus dot dot plus an plus b1 plus b2 plus bn whole square. Now again you can write the following, you can say for class 6 or 7 formula, x plus y whole square plus x minus y whole square, this is equal to 2 of x square plus y square. So these two positive and these two are obviously positive term, non-negative term. So if we add these two positive term, then we get this term, and this is also positive term. So each of these term obviously less than this term. So x plus y whole square less equal to 2 of x square plus y square, each of this term, and x minus y whole square is less equal to 2 of x square plus y square. Now we apply this one here, x square x plus y whole square, this is equal to 2 of x square plus y square. So take this is x and this is y. So that means this is less equal to, again we can write 2 of x square plus y square. X means a1 plus a2 plus n square plus b1 plus b2 plus bn square, this one. Now we just calculate mod of two complex number. So modulus of z1 plus z2 equal to, we can write, since modulus of a1 plus iota b1 and a2 plus iota b2, we know that modulus is equal to root under of a1 square plus b1 square plus, sorry I write wrong. So this is equal to real part square. So real part is equal to a1 plus a2 whole square plus b1 plus b2 whole square. Similarly, if we take three complex number, then this should be a1 plus a2 plus a3 is the real part, and b1 plus b2 plus b3 is the imaginary part. So we can write in general mod of z1 plus z2 plus dot 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 plus zn, this is equal to root under a1 plus a2 plus dot 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 plus an whole square, this is the real part, plus b1 plus b2 plus bn whole square, this is the b1 plus b2 are the imaginary part of this modulus z1 plus z2 plus zn. If we take square on both sides, then we can write mod of z1 plus z2 plus zn whole square equal to a1 square, a1 plus a2 plus n square plus b1 plus b2 plus bn square. So we can write this is equal to this, so there is no problem, and which is less equal to, so this is equal to mod of z1 plus z2 plus zn whole square, which is less equal to, write 2 into mod of z1 plus z2 plus dot 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 plus zn whole square. So we finally get, we start from here and get here. So we can write, I write in the here, so mod of z1 plus mod z2 plus mod zn whole square, which is less equal to 2 into mod of z1 plus z2 plus zn whole square, zn whole square. So if we apply square root on both sides, then we write mod of z1 plus mod z2 plus mod zn, this is less equal to root 2 into mod of z1 plus z2 plus zn. This implies mod of z1 plus z2 plus zn, this is greater equal to, we can write this is 1 by root is positive quantity, 1 by root 2 into mod z1 plus mod z2 plus mod zn, this, that means the value of k is equal to root 2. This is given in the question instead of 1 by root 2, they are given that this is 1 by k. That means the value of k is 1 by root 2. 1 by root 2. Sorry, k value is simply root 2, not 1 by root 2. 1 by k given is equal to root 2. Now comes to question number 25. Question number 25 says that consider the following system of linear equations over the field z by given 5z. How many solutions does it have? So first we note that z given 5z, this is equal to or equivalent to z5. The elements of z5 are 0, 1, 2, 3, 4. These are the elements of z5, and given a system Ax equal to b, where A is the coefficient matrix, x is the vector, and b is this matrix B. Now we write the augmented matrix. If we, and one note here, that if we apply any elementary row operations or any column operation on this augmented matrix, first we write the augmented matrix. So augmented matrix is equal to A given B, this type, and this is equal to 1 1 0 0 1 1 1 1 1 1 3 0 and 1 1 4 4 4 2. Now if we apply any elementary row operation or column operation in this augmented matrix, then there is no change in the solution and there is no change in the solutions of this system Ax equal to b. So we apply elementary row operations here. First we write R2 minus R1 and R3 minus R1. We get R2 minus R1 and R3 minus R1. So 1 R2 dash equal to and R3 dash equal to 1 1 0 0 1 1. This is augmented matrix, and 0 0 1 1 2 minus 1, then 0 0 4 4 3 and 1. Again if we apply R3 dash equal to R3 minus 4 R2, then we get 1 1 0 0 1 1 0 0 1 1 2 minus 1, then 0 0 4 R3 minus 4 R2 means they are 0, this one 0 3 minus 8, that is minus 5, and 1 minus minus plus 4, this is equal to 5. So we get this equation. If we write in the multiplication now, then we get 1 1 0 0 1, this is the coefficient matrix, 0 0 1 1 2 0 0 0 0 minus 5 into x1 x2 x3 x4 x5. This is equal to, this is the augmented matrix after the elementary row operation 1 minus 1 5. Now the equivalent equations of the systems are x1 plus x2, x1 plus x2 plus x5, this is equal to 1. Second one is x3 plus x4 plus 2x5, this is equal to minus 1, and minus 5x5, this is equal to 5. Now we start with this equation, minus 5x5 equal to 5. We don't cancel 5 from both sides, because if we cancel out, then we can't get the solution, since the solution space is z5 equal to 0 1 2 3 4. Now that means these both sides are equivalent with z5. That means this is, if we take any value of x5 from this, this is 5 modulo and this is also 5 modulo. That means both sides are equal. So we can choose x5 in this 5 elements of this 5 elements from Z5. That means choice of x5 we can choose it as 5 ways. Since there are 5 elements, now for this choice of x5 from these two equations we get this equation is independent from x3 and x4, only depend on x1 and x2. So first, if we from the equation x1 plus x2 plus x5 this is equal to 1, if we choose x5 this is equal to 0. Now these equations come x1 plus x2 this is equal to 1. Now from this 5 value we choose the values of x1 and x2. I write one ways, such one ways. If we choose x1 equal to 0, then x2 must be 1. If we choose x1 equal to 1, then x2 equal to 0 must be from these sets Z5. If we choose x1 equal to 2, then x2 must be 1, 2 plus something. We need to get 1. That means we must put the value of x2 equal to here 4. Since 2 plus 4 equal to 6, which is modulo 5 means 1. 6 is equal to, we can write 1 modulo 5. That's why this is 4. Now if we choose x1 equal to 3, then we get the value of x2 equal to again we get 3. Then 3 plus 3 equal to 6, which is equal to 1 modulo 5. And if we choose x 2 3 0 1 2 3 x1 equal to 4, then we must get x2 equal to 2. Yes, x2 equal to 2. So that 4 plus 2 equal to 6, which is equal to 1 modulo 5. So we get 5 choice of x1 and x2. For each choice of x5 we get 5 choice of x1 and x2. Similarly, from this equation x3 plus x4 plus x5, x3 plus x4 plus 2x5 is equal to -1. For each choice of x5 we get 5 choice of x3 and x4, and there is no intermediate choice between x1 x2 and x3 x4. That means how many ways we can choose? We can choose 5 into 5 into 5 ways. That means 125 ways. Clear? So our answer is the solutions, number of solutions equal to 125. This is the last question for this video. If you like the content, then please give a like to this video, share it with your friends and subscribe the channel. And if you have any doubt, then leave me a comment in the comment section below. Thank you friends. See you again in the next video.